Welcome. So this is a tutorial for the fundamentals of derivatives. And uh, in this tutorial, I will do the practice problem. I think for those of you who like didn't take calculus course, I think this tutorial will be very important for you because these are like the fundamental uh, skills that you need in order to be able to proceed with the rest of this module. Not only this module, like module the differential calculus module, but integral calculus module and the differential equations module. So basically, these are the fundamental skills that you need. So I will like, so this is what we have. We have like the power rules, the chain rules, the product rules, the quotient rule. This is some derivative of spatial functions that are handy. If you need more, you can check like tables like this, so they will have more and more of like this handy derivative of spatial functions that you can use. But let's just work on it. Yeah. So here we have an example. Like let's do this first practice problem. So we copy it down. So I'm saying like y is equal to x squared plus 8x minus 1 to the power of 4, and then like this guy to the power of 1. Yeah. So when I see this, what do I say? Like when I see something like this, what do I say? Let me delete this and write it again. So this is plus, this is x minus 3. So now I see like this is my y, and I want to find like my y, my derivative of this guy. So when I see this, oh, this looks familiar because this looks like the product rule. Yep, doesn't it? Here, let's check the product rule. So when we look our product rule, yeah, when we have like this is u and this is v, then we got something like this. The derivative of u, the function u times the derivative of v plus the function v times the derivative of. So like I can say, okay, this is u and this is v, yeah, and the at least oh, oh, okay. Anyway, it doesn't matter. So this is my function u and this is my function v. So y prime or the derivative of y, that would be like this guy, my u, x, right, the rule here. So y is equal v u, y prime, that is v u prime plus u v prime. Yeah, so my first function times the derivative of the second function, my second function times the derivative of the first function. So here, this is like my first function u or v or whatever, and this is like u. Okay, so let's do it. So basically, that would be like, yeah, minus 1 to the power 4 times the derivative of this guy. What would be the derivative of this guy? That would be like 3x to the power 2, and then this is 0. Yeah. So here I got like this guy here. This is b and this is u. Now let's do the second guy. So the second guy is like my second function. Yeah. My second function. Yeah. Times the derivative of my first function. So time like plus 8x minus 1 to the power of 4, like times the derivative of, oh, sorry, times the derivative of my first function. So how can I find the derivative of this guy? So I know like to find the derivative of this guy, I need to use the chain rule, because remember like the chain rule, I can say something like this. So here, like remember like the chain rule is like dy over dx, that is equal to du over dx. Sorry, that's equal to dy over du and du over dx. Remember that is a chain rule. So basically that's easy. Yeah, so I can say like my u, let me just, it's a different u than this guy. Let me make it, I will say d, so I wouldn't confuse you with this d, like, let's call it like w, yeah? Okay. And then I will say like, just not to confuse it like with this u here. So I will say like my w is equal to x squared plus 8x minus 1. Yeah, that's like my w. Okay, so it's like equal to this guy. So now my y is equal to w to the power of 4. Yeah, that's what my y is, like w to the power of 4. Then can I find du, like can I find this guy? du with respect to dw? Yeah, that is easy. That would be like 4 to w to the power of 3. Yeah, this is du to the ui. But I also need to find dw, this guy, with respect to dx. So I need to find like dw with respect to dx. So here, so that would be like 2x plus 8, and that would be 0. So that will give me here, so my dy with respect to dx, that will be dy with respect to dw, which is like this guy here, and dw with respect to dx, which is this guy here. Yeah. And of course, like I can substitute here for, like I can substitute my w, so I can say like x the power 2, 8x plus 1 to the power of 3. Yeah. Okay, so let's now do our, okay, and then you multiply it by this guy. So simply, like usually, like when you get used to this problem, when you see something like this, you don't even need to use a chain rule. You will just like, so here, now I'm doing, so here, like this one, like this is v y u prime. Now I'm doing like u v prime. So u, that would be like 3x minus 1, and that would be 4 times x squared 8x to the power minus 1 to the power of 3, and then the derivative of this guy inside. So the derivative of this guy inside, that would be 2x plus 8. Yeah, that's what we have here. So this guy, and this guy is this guy. Here I'm doing it step by step. Here I'm just doing it by experience. So by experience is when I see something like this, I know I just like bring this guy down and bring the power to the power of 3, like just use the product rule, but then whatever is inside this bracket, I need to find the derivative of this guy. So that is like, if you have experience, that's basically the way to do it. So let's do it again. Let's do this problem again. Yeah. Let's do it again. So to do is this guy again. Like, what do we do? Yeah. Okay. So how to use something like this? So you say like y prime is equal to my first function times the derivative of this guy. So that would be 3x plus 8x minus 1 to the power 4 times like the derivative of this guy, that would be like 3x squared plus, yeah, this guy times the derivative of this function. So this guy, that is like 3x minus 1 times like the derivative of this function. So like if you have experience, you'll say the derivative of this function is easy, you know. I just like bring this guy down, so that would be 4x squared plus 8x minus 1. Just the usual product rule, but now I need to find the derivative of this guy inside here. So that would be like 2x plus 8. Yeah, that if you have experience. If not, just like do it step by step, like use the chain rule and do it like step by step as I did it here. So this is here, right? Where, see, this is like the same as what I did here. So this is just with experience. This is here like detailed. We're using uh, the chain chain rule. Yeah. So now we've learned it. What did we learn so far? So we learned it how like this problem is nice because you learn the power rule, you learn the chain rule, and you learn the product rule. Yeah. Okay. Does this look correct? Yeah, this looks correct to me. Yeah, this looks correct to me. Yeah. Okay. Yeah. Sorry, there could be sometimes there could be mistake because this is like the first time to teach this course. Like imagine like you have to prepare tens of slides and each slide has so many things in it. Like so it's not unexpected that you will be like a mistake here or there. Yeah. But anyway, uh, let's do this. But so far, like if you find any mistake, please email me. Let me know immediately. Just email me and I will correct it. Yeah. But okay, so let's do this here. Yeah. So I'm telling you which of the following is not a correct derivative. So basically, this is all FE practice. So this is all like from FE exam. I found like made similar programs from different books. Yeah. So which is like so cosine x. What's the derivative of cosine x? So you can check it here. So cosine x, that's negative sine x. So please read the question carefully. Like in I note sometimes like in the homework you don't read the question carefully and you miss points. So please read the question carefully and see exactly what it's asking you. So which of the following is not the correct derivative? So this is like a multiple choice question and you want to find which is not. So we know like the derivative of cosine x, this is this guy. So this is correct. Yeah. So here, so this is like correct here. Yeah. Let's look at this guy. So remember like how to do this guy? Like we need to use the chain rule. So what is the product rule and chain rule? So basically like for this guy, it need to be like 3 to the power x to the power 2. And then the derivative of this guy, the derivative of this guy, that would be, what's the, that would be like 0 and that would be minus 1. Yeah. That is like here. Okay, so I will get like minus 3, 1 x minus 2 to the power 2. Yeah, so is this what I have here? Yeah, same what I have here. So got this. So this is correct. Yeah, so this guy is correct. How about this guy? Uh, so this guy, like here, like you go check the rule here. So this is like the rule that we have here. So let's just come here to this rule. Oops. And then we apply it. Yeah. So we come here. Oops, where is it? To the rule. Oh, I cannot select this guy. Okay, let's see here. I cannot select this guy, but it's okay. I mean, let me, if I cannot select it, that is fine. I can just like write down the rule. Yeah, if you cannot select it, that's fine. Just write it down. and then try to apply it. So the rule is, I have a rule here, dAx over the, here's a rule, d over dx of ax, that is equal to ax len, what's going on? That's equal to ax len a, yeah? Okay, so that is, so here, uh, does this look like anything like here? No. So what is the derivative of this guy? So let's just do it, yeah? So the derivative of e to the power x, e to the power x. If we applied this rule, so here that would be ex len e. And what's len e? That is 1. So this guy, the correct derivative of this guy is e to the power x, which we don't have here. So this is probably something wrong, yeah? Okay. I mean, you already solved it, yeah? I mean, but just to double check to make sure you already know that, like, so you can basically select this and it should be something like this. But let's do this one also, yeah? Because I mean, that's the idea of these things. So I'm telling you what is the derivative of dx for 1 over x. The way I do this, I mean, in order not to confuse myself, because I like to do things systematically, like step by step, without much thinking. So I just, do you agree? Like just for algebra, you do this. And that would be equal to what? Like you bring this thing down, so that would be like minus x, and then you subtract 1 from this guy, so that would be minus 2. That is equal to 1. That is equal 1 over x squared. Yeah, negative 1 over x squared. So this guy is correct. So now we know that this guy is correct, this guy is correct, this guy is correct. That might be the, so the correct answer is here, and you get like easy 5 points or 10 points. Yeah, let's move on. Do I have something more here? Yeah. So again, like which of the following is, wait, I don't want to show you the answer. Like which, I mean, it doesn't matter. I mean, we can look at the answer. Yeah, doesn't matter because we are solving them anyway. So which is the following is not the correct answer. So this guy, I know this guy. I mean, you should, by now, you should be familiar with something like this. So that's like, you bring the power here, that's 3x to the power 2. So this guy is correct. Sine x, this is like cosine x. Like, how would you know this? You can check it in the table. So if you check it in the table, it will tell you that on here, like on this thing, it will tell you like sine x will give you cosine x. Cosine x will give you negative sine x. So maybe you can remember something that looks like this. Yeah, where do we go here? So sine x is equal to cosine x. Yeah, we know that this guy is wrong. We did this previously, so we know that this guy is wrong. And like, let's do this one, len x. So that's where is logarithmic guys? So the logarithmic guy is here. So this is law, yeah? So let's just write it down and use it, yeah? So this is the law. So can we apply this law? Yeah, we can apply this law. So basically, like how to write down this law. So d over dx of what? Of log. Here you put the base, a, x is equal to 1 over x len a, yeah? Okay, so let's just apply what we have. So here we have like d over dx, then x, that would be equal to what? So that would be equal 1 over x, and then what is the base? So this is the natural log. What's the base of the natural log? That's e. What's len e? That is 1. So I get 1 over x. So this is 1. Because the base here, like len x is equal to log x to the base of e. That is like the len. Yeah, it's a natural log. Yeah, so log to the base of e, that will give you like len x. Yeah. something like this. So here I get 1 over x. So this is a correct answer. So again, like the wrong answer would be this guy. So again, all of these are in FE exam. You can get something similar, like one question. I mean, not the whole. I mean, just one question in exam might look something like this. Okay. I mean, let's do more of these guys. So here again, tan x. I don't remember what tan x is. That's fine. Like you just check in these tables or whatever. So tan x, that's like sec square x. And so is this correct? Is this something we have it correct? Yeah, that's something correct. So we know, like, again, read the answer, like, because these questions, which of the following is not the correct answer? So this is correct, yeah? How about this guy? So this guy here, that's like 3x squared plus 2. Yeah, 3x squared plus 2. So this guy looks correct to me, yeah? Uh, and then this guy here. So what is the rule? Again, you put the rule and then you follow it. So the rule is over dx a to the power x, yeah, a x ln a, yeah. Okay, so now I'm telling you what is the over the x e to the power 2x. Oh, now I have a problem because this rule, I have a little problem here. This rule is for x, not 2x or x plus 1 or x squared or 3x or whatever, yeah? It's just for x, but here I have like 2x. Oh, so what should I do? Well, we know that there is something called the chain rule, the trick. Remember the trick? So I can just say, oh, you know what? This is not a problem. I will just like say like u is equal to 2x, yeah? That's what I will say, yeah? And then here, that will be, I want to find like d of e to the power u. But here I'm telling you, I'm not asking you what is like du with respect to dx. So remember, like I'm asking you here what is like, this is like dy with respect to like dx, yeah? And that would be equal to dy with respect to like du, because that's like my function here. That's like, so let me write it step by step here. So y is equal to e to the power 2x, yeah? And this is what I'm asking you, like what's dy with respect to dx? So that would be dy with respect to du, yeah? And du with respect to dx. Do you agree? So that's like dy with respect, so that's my function, y is equal to 2x, and I'm telling you what is y prime, yeah, dy with respect to dx. So you substitute this guy here. Uh, so basically, let me do it step by step, yeah. Okay, so basically, like I'm telling you, this is like your y is equal to x squared, and I'm telling you what's y prime, like dy with respect to dx. So you substitute your y here. And then here I cannot solve this guy because my rule is only for x, not 2x. That's my rule. Yeah. You see, let me do it again from the beginning. Let's just start again from the beginning so that, again, this tutorial should be step by step. It should be very slowly so that you understand exactly what's going on. So my function is y, yeah, e to the power 2x. That's my function. And I'm asking you, what is dy with respect to dx, which is equivalent to this guy, yeah? So that's what I'm doing. So how to do this? Again, this is my rule here above. Above, this is the rule. So how to do this? So basically you say like d, you substitute your function d over dx of my function like 2x, yeah? That's equal to what? Here's a problem is my rule is does not tell me is to the power of x, not 2x or x squared or x cube or cubic cube of x or sine x or anything like this. It's just like to the power of x. So how could I get rid of this guy, like this 2x? Well, we know that there is something called the chain rule, like the trick. So I can say like u is equal to 2x. Yeah, I can just make this. Then my function will become, if I said like u is equal to 2x, then my function will become d over dx e to the power u. Now I can here apply my rule very easy, yeah? So here, that will give me what? So like if I applied my rule here, so that will give me a, which is like e to the power u, and then len a, which is like e, so that will give me e to the power u. But what did I find here? I'm finding here dy with respect to du, but I want to find dy with respect to dx. So how to do this? We just like use so here this is like d, sorry, mistake here. This is dy with respect to du. Sorry, this is typing. So here I'm finding like dy with respect to du. Yeah, here. See, like this is dx with respect to dx, dy with respect to du. But I want to find dy with respect to dx. So that is easy because I can say like dy with respect to dx, that is equal to dy with respect to du, which is like this guy here. I can further substitute this guy here because I know that u is equal to 2x, yeah? U is equal to 2x, so I can further substitute this guy here. Time du over dx. Why this is a trick? Because here, like this u could cancel out with this u, then I get dy over dx, yeah? So now what is dy over dx? So that would be du dy with respect to du, which is like uh, uh, what we have here. So that is like, okay, e to the power 2x, what we got here, time du with respect to dx. So here, this is my du. I can say like, what is du with respect to dx? And that would be equal to 2. So that will be equal to 2. So that will give me 2 e to the power x. And again, like, this is similar to what I told you previously. So here, like, the 2 is missing. So this is wrong, yeah? So this is similar to what I told you previously. Like, you do these things by experience. So you know that your rule is, uh, you know that like derivative of e to the power x is ex, like you get the same. But here, this is not e to the power x, this is 2x. So you know that you need to use the chain. You need here, like, sorry, 2x. You need to use the chain rule for this guy, so you need to multiply it by 2, yeah, to choose to use the chain rule for this guy, and that's why this is the correct answer, yeah. But anyway, you can just do it also like step by step, like this here, yeah. How to do this guy? Remember, like 1 over x. We did 1 over x before, so like, I mean, I can do it again. So the x 1 over x, that's x minus 1. So that would be what? Like you bring this minus 1 here, you subtract 1 from here, so that's minus 2. So that would be negative 1 over x squared. Yeah. So basically that would be the right thing here, yeah, to do. Okay. Okay. One more or a lot more. How do we or do it? Don't want, I mean, this tutorial, I mean, I can keep it as long as it needs to be, but I mean, I also don't want to keep it so long. Okay, so look at this guy. Okay, what is the rule? You write the rule and then you follow it. So the rule for this guy is d over dx log a x is equal to 1 over x len a. That is the rule for like len, yeah? But again, I have the same problem here because it's not x. This is like 3x. So I need to use my chain rule. So if I need to use my chain rule, like in order not to complicate yourself, and use the chain rule just from your experience, just do this, just do it from your experience. So I will just solve this by experience. So by experience is I need to do the chain rule, which means what? Which means I will just assume that this is, let me show you. So I will uh, let me do this one. So here that would be like equal. So here d over dx, then 3x, that is equal to 1. So that is equal 1. I will just assume that this is x, so that's like 3x, yeah? And time len a, what is a? A is like e, so that's 1. And then I know I need to find the derivative of this guy, so time 3, because I need to find the derivative of this guy. How did I do this? Well, I just applied like the chain rule. So let me do the chain rule one more time and show you like how I did this like step by step. So that is my rule. Yeah, so how to do this step by step? You say like your u is equal to like 3x. Yeah, then dy over dx, that would be like du dy over du time du over dx. Du over dx, that is like equal to 3. Yeah. Now dy over du, so like this is, so again my y function is like uh, len 3x, that's my y function, yeah. And then that is equal to len d. That would be like d len u over du. And can we apply the rule here? Yeah, so the rule here states that len of this guy, that would be equal to 1 over, what's my x, like u, and what is len a, uh, so that is like len, the base 1 over x, yeah, 1 over x, yeah, that's what I got here, yeah. Mm. So here I got like, for this guy you got 1 over x, yeah, that's what I got here. Okay. Uh, okay, so this guy, so this guy is correct. Now let's do this guy. Yeah. So let me delete what we have here. Yeah. Delete, delete, delete. And let's do this like go sine square x. So how can you do this? Well, I will maybe, let me do the, you can do it like different ways. I will like the easiest way for me, like for lazy, like, yeah. Basically you say like cosine x times cosine x. So that is like my y is cosine x, my cosine x. So I say like y prime. So I will say this is like my u function and this is my v function. So what does this mean? So here that would be like that would be cosine x. So I'm doing like this guy, and the derivative of this guy. Remember, like here u, that's like u v prime plus v u prime. Remember, like this is the product rule. So I'm just like applying the product rule. So I put cosine x time negative sine x, yeah, plus probably the same, yeah, cosine x also like negative, because negative sine x, that's how I do it, yeah. So that will give you negative 2, because I have like two of them. You can take this as a common factor, so you'll have like two of them. 2 negative 2 sine x cosine x. So this guy is correct, yeah. How about this guy here? So this guy here, dx over this guy, so I can write this guy dx over 1 over x over 2, yeah. And what is this? So basically, what is the rule? So the rule is like you bring this guy down, so this is like 1 over 2, yeah, x, and then you subtract 1, so like half minus 1, so that will give you like negative half, yeah. So basically that is what it brings this guy down, so that is like I could bring this guy down, so that is will be 1 over x to the power of half, yeah. Just like brought this guy down, and then that could be 1 over 2 square root of x, yeah. This is what I got. Yeah, I got the same guy here. So this is correct. Now, by just looking at tell you that this guy is not correct, yeah, because like how do you solve this guy? You solve this guy like using the chain rule, yeah. So I mean, let me just solve it by experience. So by experience is that I will know like that sine x will give me cosine x. So that like, so sine the derivative like, so here x square over dx. So by experience, I know this will give me cosine x square times the derivative of this guy. So the derivative of this guy would be like 2x. Yeah, that would from my experience. But here, I mean, it's just like something wrong. So that's the correct answer. Yeah, 2x cosine x square. Yeah. Again, how did I do this? Let me do the chain rule for one more time. I mean, if this is getting boring, you can skip the video. If you still need more practice, let's do more practice. Yeah. So how did I do this? So basically, I said like, let me just do it step by step, very slowly. If you need, you can skip the video if you already know it. So you can, so y is equal to sine x square. Yeah. And I'm telling you, find like dy with respect to dx. Yeah, that's like what we need to find. We know that sine, the derivative dx of sine x, that is equal cosine x. We know this, yeah. Let me delete this. So let me delete. Oh, okay, so that's our rule, yeah. But unfortunately, this is x, not x squared. So, well, I know I can do a trick. I can, the trick is I can say it's not a problem. I can say u is equal to x squared. Yeah, that's like, I can make this trick. So now I can say dy over dx, that would be dy over du, and du over dx, because here this du could go away with this du, then you get dy over dx now. So now what I need to do is what is dy with respect to du. So now y, let me just write, is equal to sine u. Yeah. So what is dy with respect to du? So dy with respect to du, that would be co like sorry, dy with respect to du, that would be d sine u over du, and that would be cosine u. And I know u is equal to 2x, so I can say cosine x square. Yeah, I can know that this is like 2x, so that's like equal to cosine like x square. Yeah, so this is good. Yeah, and then I need to find like du with respect to dx. So du with respect to dx. So d du u is x square with respect to dx. So that will be equal to 2x. Yeah. So now, so this I got this guy here. I got like this guy here. And does this look the same as what I did here? Yeah. So basically, like when you see these things, like don't waste your time like doing this because that could be tedious. Just know, like you can just solve it by your experience. So just like so when I see something like this, I will just say, okay, what is the do I have here or do I have more? Yeah, I mean, uh, oh, now this is like a little bit. So basically, I am telling you. So here you have to do more things. I'm telling you like this is your y is equal to x sine x squared plus 1 and I'm telling you find like the derivative of this guy. So the derivative of this guy I will like use the uh, product rule. So the product rule y prime is equal to u v prime plus v u prime. Yeah. So this is like my u, for example, and this is my v. I know this will be like 0. Yeah. So I don't need to worry about this guy here. So here, let me just like do this. So basically, like you put like your first function times the derivative of your second function. So sine x squared, that will give me like cosine x squared, and remember like chain rule, then time 2x. Yeah. So that would be this guy, and then plus you put like this guy. Yeah. So that would be like your second function sine x squared times the derivative of this guy, which is 1 basically. Yeah. So that would be 1. Okay. So this basically will give you, so that will be equal, like if you just arrange this term, that would be 2x square, 2x square, yeah, cosine x square plus sine x square. So that is like my solution for this problem. I got, yeah, I got, yeah, two, yeah, yeah. So that's basically how to solve a problem like this. Okay, let's look at your homework problem. So, I mean, by now this should be trivial, and like if something like this is still not clear to you, like if this is true or false, then please watch all these videos again. If the videos are not clear, check any of your mathematics books. If your mathematics books are unclear, check other like YouTube videos. If all this is not clear, please contact me and I can maybe walk you step by step. But that is something very basic, and you really need to be able to do this. Like after the videos and the tutorial, like if you cannot do this, that I would be like a little bit worried. Yeah. Uh, okay, so this is for sure. That must be true. Yeah. Here, like we did this guy a lot. So you remember like len 1 over x is 1 over x, but then you need to get the derivative of this guy. So you know, yeah, that this should also be true. You can do this guy. That's also trivial. So trivial, and this by now should be also like trivial. Yeah. So basically, like your homework is telling you like select like this is true or false. Yeah. And so you should easily know this. You should easily know this. You should, but after this tutorial and after this video, you should easily, I mean, they are all trivial. Yeah. Same here. Like we just did like in this tutorial, we did like so many of this guy. So, oops. So this guy is like similar to this guy here. Like you need to use like the chain rule or just solve it by experience. Yeah. Here, like similar, like you need to use like product rule, like and the chain rule here. So you need to do this, and we did like in the tutorial, we had like one of these guys. Here, this is the quotient rule. Like I didn't show you like an example for this one, but I mean, I showed you like in the main video an example. I didn't have a tutorial for this one, but like the rule is simple. Yeah, you can just like put in the rule. Let me write it down here. So the rule is simple. Like you can you can just like write it down and follow it. Yeah. So the rule is, so you can say that this is like u, yeah, and this is like v. That's basically how you do it. And then dy with respect to dx, that would be equal like v, yeah, u prime minus u v prime over v square. Yeah, so this is u, this is v. So basically, like you put this function, yeah, you put this function uh, time the derivative of this guy minus this function times the derivative of this guy, and then you square this guy, and then if you did it, like see if this is what you will get or you'll get something else. Yeah. Okay, so that is all for this tutorial, and yeah, see you in next videos. Do I have more?